Hey everybody, this is a quick video on how to rationalize denominators with a radical. So I have 4 examples here, and I'm going to kick it off with the first one being the easiest and the last one being the most challenging out of the set I have made. So let's begin. The key idea is to eliminate the radical from the denominator. And one quick way to do that is, if you look at this example, one quick way to do that is to take the radical in the denominator and simply multiply it against itself. Now the reason for doing this, and I'm going to swing off to the side here, is because when you multiply a radical to itself, what happens is you get a perfect square. And the square root of 9, as you probably know, is just 3. So to shortcut this, when you have 2 of a kind, what you get is just the number inside. So if I bring that back over here, when I multiply to the denominator, I also have to do the same in the numerator, since they are joined, and then I need to go ahead and multiply across. So you go sideways. 1 times the square root of 3 is just the square root of 3, or radical 3, and the square root of 3 times another square root of 3 is radical 9, which, as we know from over here, is just a regular 3. And just like that, my answer is radical 3 over 3. Now, you may be tempted to cross these two out, but that actually would be very wrong. You don't want to do that. And the reason you want to avoid doing that is because this radical 3 is on the inside, or I should say there are 3's on the inside of a radical, but this one is on the outside, and there is no radical there. So if you were to enter this into a calculator, what you would actually get is something like a decimal, 1 point something. And that is not the same thing as 3. So because they are not equivalent to each other, you cannot simply divide them out. So what you want to do is leave it alone. Okay, so that is the answer. All right, example 2. You have 5 over radical 50. Now, once again, you might be tempted to reduce 5 and 50, but don't do that, because the 5 and the 50 are not the same. They're not actually divisible by 5. Okay, so the square root of 50 again is going to be a decimal value, and what you want to do is you want to keep this number inside the radical, and instead you want to focus on splitting this 50 into 2 smaller radicals and trying to pull, if you can, a perfect square out of there. So this 5 will stay up here, and the square root of 50, I can rewrite this as the square root of 25, and the square root of 2. And then I can see over here, oh, I have a perfect square. Right over there, the square root of 25 is going to be just 5. So I can rewrite this now as 5 over 5 square root of 2. And because the 2 5's are on the outside, now it is safe to go ahead and divide them. So that means that they cancel out. And what you're left with is just 1 over square root of 2. Now you might be thinking, well, okay, I'm done. But you're not. And the reason you're not is because you have this radical 2 down here. And as we started this video by saying, you cannot have a radical in the denominator. So how to get rid of it? Easy. You just make a duplicate of it and replicate it up here. When you multiply sideways, just remember you're going to multiply this sideways, side to side, and what you're going to get is the square root of 2. And down here, what you would get is the square root of 4. And the square root of 4 is just 2. So that would be the answer. Okay, so in case you might have missed that, I'll put it over here. From these two, what you get is a square root of 4, and what you get from that is just the 2. Okay, so there you have it. And again, once again, I know I kept saying this before, but do not cross these out, because one is a radical 2 and the other is a 2 by itself with no radical. So they are not equivalent values. All right, let's go on to number 3. In example number 3, we have a number on the outside, which is the 4, and on the inside, this time we have variables. So we have c to the 2nd power and c to the 3rd power. There are different ways of approaching this question, so I'm going to only present you with one way of doing it, but I encourage you to explore other ways as well. One way of doing this is to notice that these are both inside a radical, and because of that, you have permission to go ahead and reduce them as if they're just regular fraction without a regular fraction, without a radical symbol. So what you would do is you would borrow 2 c's from up here and 2 from down here, leaving you leaving you with 1, and then you have to rewrite what you have. So at the top, the numerator, I now have a 4, no more radical because I used up all 2 of the c's that I had. I used them all up, so they are gone. And in the denominator, I have only 1 c left, and it's inside the radical still. Now, I cannot obviously reduce 4 with the radical c. So what I can do instead is try to get rid of the radical c. So once again, the way you do this is you duplicate it and repeat it. And then you multiply side to side. Okay, side to side. So what you get when you do that is you get 4 times the square root of c, or 4 radical c. And in the denominator, the radical c times another radical c will simply be radical c squared. Now, one thing about radicals and squares, or squares and square roots, is that they are exact opposite operations of each other. So just like a minus can undo a plus and a times can undo division, a radical, or a square root in this case specifically, and a square can undo each other. And that's good news for the c, because this guy just comes out and goes straight to the denominator, and now you're done. Just like that. And you probably figured I was going to say this. Do not cross these out, because one of the c's is on the inside of a radical and the other c is on the outside. So they cannot cancel and make a 1. All right, let's go to the last example. This is the most challenging example that I have for this video. And in this one, I've mixed quite a few things. So let's go ahead and break them down. On the outside, you have a 5 and you have a 2. Now, you always want to see if you can reduce the fractions with the numbers or the values and things you have on the outside. If you have, for example, a 5 or a 10, you would have to make that 1 over 2, and so on and so on. Well, in this case, we have only a 5 and a 2, and you cannot reduce them, so we keep them as they are. So I'm going to keep them the way they are for now. So 5 and 2. Okay? Now on the inside, we have something that we can do, because on the inside, I have a 3. Let me do that again. I have a 3 and I have a 6. So because 3 and 6 can be reduced, I'm going to go ahead and do that. So dividing each by 3, this now becomes a 1 and this becomes a 2. But that's not all, because I also notice I have an a to the power of 1 and I have an a to the power of 4. And what that means is I can borrow 1a from here and 1a from there, and I have now 3 left over. Now I need to clean this up, so I'm going to go ahead and move on to my fraction on the right side and write down everything I have left. So in the numerator, once again, I have just a 5 because everything else is now gone. And the denominator, I have my 2, but I still have a radical, and I still have a 2a to the power of 3 on the inside. Now, as I've been saying this whole time, you cannot have a radical down there, so if you find yourself stuck with one, even after doing something, that means your work is not yet finished, my friend. So what you need to do next is find a way to get rid of the radical. So what we want to do is you want to notice right over here, you have a to the power of 3. Now, remember what I said earlier. Only a square can eliminate a square root, right? You can see it right there. It's right over there. So we want to try to find as many squares as we can and pull them out of what we have in that yellow circle. So the way we're going to do that is like this. We're going to continue. We're going to bring this 5 right over there, put the 2 right over there, but we're going to split this radical into 2 pieces. One of them will say radical 2, and the other will say a to the second power, and the other one will say a to the first power. Now, if you're wondering, whoa, why did you do that? Where'd you get that from? Here's where that comes from. The idea is that when you when you take the 3 and you try to extract as many powers of 2 from it, you can only pull out one single power of 2 from it. And what's left over is simply a power of 1. Because 2 plus 1, as we know, is 3. So that's where that came from. Now, if you can see one step ahead, you might know that the next step would be to cancel this and to cancel that, because as you know, a square and a square root do eliminate. However, when you look at this little guy, the power is not high enough to cancel the radical. So that is going to stay on the inside. And then I move on to the next step. So now I have 5 over 2 radical 2a. Okay, these are all the things that are left on the inside that could not be taken out. No matter what I did, that was all that remained on the inside, and they're stuck there. So once again, before I decide that I'm done, I have to think, well, do I have a radical in the denominator? And the answer is, well, yes, I do. And that means my work is not yet finished, but it's almost there. So what I do now is what I did before. Now that I've simplified everything I could possibly simplify, now my focus is just get rid of the radical. So here we go. We're going to multiply to a radical 2a, and we'll repeat that up here, radical 2a. And then you multiply sideways, so this way, and this way. And what you get is, in the numerator, 5 radical 2a. And in the denominator, what you're going to have, and I'll slow down over here, this 2, which is this 2 right here, okay? That 2, I'm still putting it in front. However, when I multiply these 2 radical 2's together, what I'm going to get, and I'll put it over here so you can see, what I'm going to get are 2 of them. So radical 2a, I have 2 of them, right? That's what this power is for, 2 of whatever's inside. So I have 2 radical 2a's. And as I said before, whenever a radical or a square root meets a square, they cancel out, and whatever's inside just comes right out. So I'm going to bring that one over there, and I'm going to multiply it to the 2 that's already there this whole time, like that. Okay, so now we're at the finish line. Now we can finish this up. Alright, so what I have in the numerator is 5 radical 2a, and what I have in the denominator is 4a, and then we are done, just like that. Okay, and final time I'll say this, I promise for this video, please do not cross out the a's, because one is inside the radical and the other is on the outside. Also, the same thing with the 2 and the 4. You cannot reduce those because the 2 is inside the radical and the 4 is not. So I'm going to zoom out here so you can see all the work it took for this one to be completed. Once again, as I did say at the very beginning, there are different ways of doing this. So if you have a different method, then I encourage you to explore maybe picking up a second method to that one and finding which method is most efficient in getting from the beginning to the end. Thank you very much for watching this video. I hope it helped. Please stop by and leave a comment, and I'll see you next time. Bye-bye.